Alright guys, so we're going to continue our chat about equations, but this time we're not going to talk about equations with radicals, but instead we're going to talk about equations that have rational exponents, which if you remember from lesson 1, it's actually just another way of writing the same thing, but it looks a lot different, so it's worth doing a separate lesson for. So let's go ahead and jump in and take a look. So first of all, let's review some stuff. First of all, you guys remember that a rational exponent, that means you have an exponent that's a fraction. So like here we have a to the power of t over b. So my power is a fraction. As we learned back in lesson 5.1, the denominator is what makes like the index of your root, and the numerator of the fraction is what makes the power. It's going to go outside these parentheses. Okay? And so that's the kind of stuff we're going to be looking at. Another thing that we want to remember is that when you have an even root, you always get two answers. They're either both real or they're both imaginary. It just depends on whether the inside is positive or negative. If the inside is positive, then you get two real answers. If the inside is negative, then you get two imaginary answers. But if n is odd, then it's pretty simple. If your inside is positive, your answer is positive. If your inside is negative, your answer is negative. So that's something else that we learned back in lesson 5.1. So now that we know that, let's go ahead and give you guys some steps that we're going to use to solve these equations. Before we do, I guess I'll show you the equations. So here's some equations, and these equations, as you can see, have powers that are fractions, and we need to know how to solve those. So let's talk about how to solve them. Here are the steps. The first thing is, once again, we're going to get rid of any numbers that are not under the influence of that exponent. The next thing we're going to do is we're going to get rid of the exponent. And the way that you do that is you raise both sides to the reciprocal power. The next thing that we do is we're going to simplify the expression using what we've learned about rational exponents, and we should be able to solve after that. So there's our 4 steps. So let's go ahead and put those 4 steps to work for us here. So step 1 was to get rid of any numbers that are not under the influence of the power. So right now, as we're looking at number 1, the only thing that's being affected by the power here is the n. The n is being raised to the 3/2 power, but the 3 there is not. So I'm going to go ahead and get rid of that 3 by dividing it on both sides. So I've got n to the 3/2 power equals 512. Now here's the second step. Second step is I want to get rid of the power. I want to get n by itself, right? So I need to get rid of that 3 over 2. How do I do that? Well, here's the real step. You're going to raise it to the same power but the reciprocal. So it's going to be raised to the 2/3 power. Now the reason that we do that is because when you raise an expression to a power that already has a power, you multiply those powers together. But if you multiply a fraction by its reciprocal, they cancel each other out. So all I'll be left with here on the left is n now. But don't forget, whatever you do to one side, you have to do the other. So since I raised the left side to 2/3, I need to raise the right side to 2/3. Okay, so now we have to move on to step 3. Step 3 is where you are actually going to simplify this expression using what you've learned about radicals. Or not radicals, rational exponents. So the first thing we're going to do is we're going to change it into a radical expression. The 512 goes here, the 3 goes here, and the 2 goes out here. And as you guys know, we want to break down our 512. And if you break down that 512 correctly, you would end up with 9 2's. Now we're looking for groups of 3 identical numbers, right? So we have one group here, so I could take out a 2. Got another group here, so I can take out another 2. And I've got another one here, so I could take out another 2. No more radical. We can go ahead and put those 2's together there and get 8. 2 times 2 times 2 is 8. And then 8 to the second power is 64. Now, once again, though, you kind of have to make sure that your answer is good. We have an odd root with a positive number. When that happens, you should get just one positive answer. So don't forget to double check to make sure that you have both possibilities available. Okay? All right, so that's number one. Let's go ahead and see what's next. Let's do number two. All right, so step one is to get rid of any number that's not being affected by the power. But in this case, the power is outside of a pair of parentheses, and inside the parentheses is everything else. So that means that everything inside that parentheses is under the influence of that power. So we're going to skip step one because there are no numbers that are not under the influence of that power. So we're going to skip step one and move on to step two. And once again, step two is where you're going to raise both sides to the reciprocal power. Once again, it's going to be 2/3 again. On this side, all you're left with is 4v plus 32. And now on the left side, we have 1,000 being raised to the second, or the 2/3 power. So now we go ahead and we rewrite this as a radical. We're going to break apart that 1,000 there, as much as you can. You're going to end up with 3 5s and 3 2s, if you do it correctly. So we're looking for groups of 3 again here. So I'm going to take out a 5, and I'm going to take out a 2. 5 times 2 is 10. And 10 squared is 100. So that's the end of step 3. So now we move on to step 4, which is basically just solve what's left. So we have a simple equation here to solve. So we're just going to minus 32 on both sides. And we divide by 4 on both sides. And we get 17 as an answer. But we want to make sure our answer makes sense once again. Remember, we had this, right? We had the third root of 1,000 squared. Well, the third root of 1,000 should be a positive 10. And when you square it, it's still positive. So we still end up with just one answer. Once again, we got to be careful to make sure that our answers are matching the type of root that we're dealing with here. All right, let's go ahead and take a look at one more problem here. Let's do number 3. All right, so step 1. Step 1 is to get rid of any number that's not under the power of, or the influence of the power 2/3. So everything in parentheses is under the influence of that power. So we need to get rid of the 6 and the 4 there. So, and once again, just like most other types of equations, you always do your addition or subtraction first. So I'm going to add 6 on both sides. Then we're going to divide both sides by 4. So that's the end of step 1. We got rid of all the numbers on the outside. Step 2 is we want to get rid of the power. So I'm going to raise both sides to what power now? 3/2. I want to do the reciprocal of whatever this one is. So in this case, this is different this time. We're raising both sides to the 3/2 power. And once again, these cancel. So I'm going to be left with x plus 5 equals 16 to the 3/2 power. Carry that on up to the top. All right, and we move on to step 3, where we will change this into a root. All right. Now this time I want you guys to notice that we're taking a square root. Now when you take a square root, your answers can come out a little bit different. First of all, I want you guys to notice that we're looking for groups of 2, so I'm going to take out a 2 and another 2. But remember, when you take an even root of a positive number, you get a positive and a negative answer. So what we have over here then is plus and minus 4 when we multiply those 2's together. And when you have a plus and minus 4, if you raise positive 4 to the third power, you're going to get 64. And if you raise negative 4 to the third power, you get negative 64. So by raising it to the third power, basically, we just get plus and minus 64. Now, if you come across one of these situations where you have a positive and a negative answer because you're taking an even root of a positive radicand, then you're going to get 2 answers because you're going to need to write 2 equations. Okay, so starting back up here at the top, then we have this, right? So that means that x plus 5 is equal to 64, but it's also equal to a negative 60. Okay, so we're going to minus 5 on both sides. That one, I'm going to get 59 here. And then if I minus 5 on both sides here, I'm going to get negative 69. So this one we get 2 different answers. So if you ever have a situation where you're taking the square root of a positive number, you should end up with a positive and a negative result that you're going to end up getting a positive and negative for, so that'll give you 2 different answers. Okay, so there's your same basic 4 steps every time. So here's a practice set for you guys. Now, number 3 is a little bit tricky, but I'll let you guys see if you can figure it out. Okay, the reason it's tricky is because the exponent's also negative, but we've talked about what to do about that in the past as well. Okay, so see if you guys can figure out number 3. If not, that's okay. 1 and 2 are great sample problems. 3 is just an extra little bonus practice. All right, guys, here's your solutions. Number 1 was negative 17. Number 2, you had 2 answers, 157 and 29. Number 3, you had 2 answers, positive and negative 8. So for number 1, you raise both sides to the 3/5 power. 3,125 raised to the 3/5 power is going to be, ultimately it comes out to be 125, but the 5th root of 3,125 is 5. Raise that to the third power, you get 125, and you just solve. As for number 2 here, you start by dividing both sides by 5. Raise both sides to the 3/2 power. Then you do the square root of 16 cubed. Square root of 16, though, we're going to get a plus and a minus 4 because we have an even root of a positive number. So when you raise that to the third power, you get 2 answers, positive and negative 64, so we get 2 equations. And solving both of those, we get that. This one is probably the most confusing to you, and that's okay. I was just kind of giving it to you, make you think a little bit. If you raise both sides to the reciprocal power, you get this. Notice the negative went along with it. Now, when you raise a fraction to a power, you raise the top and the bottom to that power, but no matter what power you raise 1 to, you're always going to get 1, so I just left that as 1. But 16 to the negative 3/4 power is down here and simplified. But what did we learn about negative powers? Well, what they do is they make reciprocals. So instead of this being 1/16, it's just going to flip it upside down so it becomes positive 16. Instead of 1/16, we end up with 16. And then we do the usual protocol where you put the here, the 16 and 3 here, take the 4th root. The 4th root of 16 is 2, but once again, even power, positive radicand gives you a plus and a minus. So there you guys go. That is solving equations with rational exponents.